Okay, worksheet 5 had a lot more challenging problems on it and kind of a little bit of everything. So the first 4 problems ask you to use change of base formula to find the exact answer in terms of log, and then use your calculator to find the approximate answers. So when you see log base 2 of 20, I want you to know you either could take the natural log, so I put common logs on here, but you definitely could have written it as natural log of 20 over the natural log of 2. So it's always a log of some base of the number you're taking the log of divided by the log of your base. So if you want to write it as common log of 20 over common log of 2, that's fine, or natural log, because both of those buttons are on your calculator. So if you take the log of 20, just make sure that's in parentheses, divided by the log of 2, you should get 4.32. Okay? And to check it, you could say that means 2 raised to the 4.32 power is about 20. Now, it's not going to be exact because you've rounded that answer, but you can always double check it. 2 raised to this power should be close to 20. Same with this one. Now, when I originally did this one, I thought that was a 25, but it is a 0.25. So the log of 10 over the log of 0.25, the log of 10 I know is 1, so I just put a 1 there. You know, you get to use your calculator, so if you realize that, oh, that just is 1, that's fine. The log of 0.25 is negative 0.6, so when you do that division, you should have gotten negative 1.67, it looks like. Number 3, same thing, log of 8 over the log of square root of 5. Exact form, if you can have a calculator to check it, it's 2.58. And then log of pi of e, I use natural log on this one because, again, I know the natural log of e is 1. So I took the natural log of e over the natural log of pi. 1 over natural log of pi is 0.87. Now, if you use common log, I can't mark it wrong. Okay, so that's just making sure you know change of base. The next 2 problems is, again, using change of base. This was without a calculator. So before you worry about what's going to happen, because this looks kind of complicated, use your change of base. So when I looked at this, I said, all right, let's take the common log of 4 over the common log of 2. This one's common log of 6 over common log of 4, and common log of 8 over 6. We're multiplying these together, and what you should have noticed is that some things canceled out. And so I was left with the log of 8 divided by the log of 2. You should always think about when you start to see that you have bases that are the same or that can be put into the same base, then put it back into log form. So if this is log, let's go backwards with the change of base. This really means I could take the log base 2 of 8. And 2 raised to what power gives me 8? 2 to the 3rd. So that does actually come out to a number. This one, you do the same thing. Everything's going to cancel, but the log of 6 over the log of 2. Again, that really can't be simplified, but we can write it as a common logarithm, log base 2 of 6. Okay, so that's just making sure you know change of base, and that you see sometimes things cancel out to help you out a little bit when you're using change of base. All right, so the equation part of this worksheet tells you that you're supposed to find an exact answer like we did on all the other worksheets, but then they want you to use a calculator to approximate your answer. The reason I did this is on some of these, there's different ways to write it. So I just want to make sure that you get the right answer. With this one, it was just pretty simple. 2 logs, same base, equal to each other, so x plus 2 is 8, x is 6. Didn't really need a calculator to even check that one. Number 8 is an exponential, so again, it's just log base 2 of 10 has to equal x. That's really your answer, your exact answer. But to get that on your calculator, you can use change of base and say the log of 10 divided by the log of 2, and you should get 3.32. So use the change of base to put that on your calculator. Log of 10 over the log of 2, 3.32. 9 is a log equation. Again, we have a number over here, so we first want to do our laws of logarithms. So we're going to write it as the natural log of the product. We're going to put it in exponential form. E is our base. E to the 4th has to equal this number, or this value. That is an exponential, or that is an exponential. That is a quadratic, sorry. E to the 4th is just a number. So that's going to be your C value. So you've got x squared plus 2x minus e to the 4th. So use your quadratic equation. This is all you can really do as an exact answer, you probably could factor out a 4 and pull out a 2 to make it a little simpler, but if you're going to use your calculator anyway to get a decimal approximation, you get 6.46. 10 is an exponential, so a couple ways you could do it. The way I did it on this worksheet is I started over here and said log base 4 of all of this has to equal x. So I actually went from exponential form to log form. Now, when you get to this, you got a problem because there's an x over here and there's an x over here. So we need to get this x out of being an exponent. So the power property says we can bring it out in front. So I have 1 minus 2x, quantity, that whole quantity, times the log base 4 of 3 has to equal x. Now we got x's on both sides, so how are we going to solve for x? We have to distribute this log base 4 of 3. So I got log base 4 of 3 times 1, and log base 4 of 3 times negative 2x gave me this. I have x's on both sides again, so I need to collect the x terms on one side. So I added 2x log base 4 of 3 to both sides. The reason we collected them over here is that now I have two terms, they have an x in common. So I factored out the x. I'm left with a 1 here and a 2 log base 4 of 3 on that term. Now to solve for x, now I can divide by this coefficient, 1 plus 2 log base 4 of 3. So that's my exact answer, and now the decimal approximation, I got 0.31. So when you have a little bit more complicated ones, and you have variables on both sides, use your power property, but remember, you kind of have to like distribute everything to get all the terms separated. Any terms that are x terms put on the same side, factor out the x, and then divide. All right, on the back. Let me look at, we'll start with 12. Well, let's do 11. I think we can get 11 done. 11, I think when I did 11, because 11 is very similar to number 16. When I did this one, I think I originally didn't mean for these to be different bases, but after I did it, I thought it was a good problem. And so when I originally did it, I didn't notice they were the same bases. That's why you see this crossed off. So since they're different bases, I have to work with a change of base. So if I see the log base 2 and a log base 4, I decided I'm going to change it to a log base 2, because this one then can stay the same. This becomes the log base 2 of x over the log base 2 of 4. Now I picked that because this one already was a 2, and now when you look at this using change of base, log base 2 of x over log base 2 of 4, I can evaluate or simplify. Log base 2 of 4 is 2, because 2 squared gives me 4. So I can replace that with a 2, and now I can go through and solve. So I've multiplied everything by 2 to get rid of that 2. So that's what I have right here. I need to take care of this power, so I brought that up as a power. So it's 3x plus 2 squared. And then since I'm minusing the log base 2 of x, I can also put that as a quotient. So it was the log base 2 of 3x plus 2 squared divided by x. Now I've got a log equation. So after all of that, I'm down to a log equation. Now I have to put it in exponential. 2 to the 6th power is 64, equals this expression. I multiplied both sides by x to get rid of that fraction. It's a quadratic, so I subtracted 64x to get this quadratic, set equal to 0. I used the quadratic formula. This is really all I could do probably without a calculator, without doing a lot of arithmetic. You could leave it like this, because I was going to use my calculator to get the approximation anyway. So I got 5.7 and 0.08. Okay, so again, what we did is we had to use change of base, log of x, log base 2 of x over the log base 2 of 4. That log base 2 of 4 simplified. We had to get rid of that fraction, and once you have logarithms that are the same base, now you work to get them to be the same, so you can combine them together into one log, putting it in exponential, and then we had to solve the quadratic. 16 is very similar to that. We use log base x. I guess I use common log on this one, so maybe on the next video I can talk about 16 as well and show you like both ways to do that problem.